This video is going to explain how to graph absolute value equations. So, first thing you need to know is what is a parent function. A parent function is the most basic a function can be. In case of an absolute value, this is the most basic can be, just having one x, just having x there. So, this is what a parent function of an absolute value sign looks like. So it's a v. Okay, all of these are going to turn out to be v's. So first thing I showed you is the parent function and shown you how manipulating some things can just make it move. For example, we start right here. Okay, we moved 6 to the right and moved 2 down. So what you'll notice is that these numbers mean something. This means move 6 to the left, and this means move 2 down. This one, we'll notice that we have this 3 here. This was not in, we did not have a number there before. We had no number there before, but now we do. So that means something. Well, let's compare. The last one, the size of the V did not change. In this one it does, it gets smaller. But you also notice that moving over 1 and up 3 still represents these two numbers. But this 3 tells you to shrink this thing. It's essentially the slope of 1/2 of this line. So if I showed you if we started here, we were getting to the next point, you go up 1, 2, 3 over 1, you notice that's the same number. So that's a brief explanation of what absolute values do and how they use translations, which we'll get to later on, to actually manipulate the equation. Now, this is the standard form of an absolute value function. So you have negative h plus k and there's a. Now I called it slope in this one, but technically it's the stretching and shrinking, but we can go with slope. A, h, and k. The h represents the value, x value of the vertex. Now the vertex, guys, is this. Is where the two lines meet. That's called the vertex. That's why the x value, okay, is the 1, the y value is the 3, or the h is 1, the k is 3. The h is 1, the k is 3 in that case. So h is the x value of the vertex, k is the y value of the vertex. And a is just the slope, or how much it shrunk or stretched. So we're going to look at this first one. As you can see, this is the parent function because it started at 0, 0. This one right here is what we're looking at. And the dot I just made is called the vertex. It's where the two lines meet. So first we're going to find our h, meaning the x value. Well, the x value is 3, so we're going to write 3 down. K value. The k value is the y. There's the vertex. There's the y value. So it's 4. And finally, the slope, or how much is shrank or stretched. You can tell this by going from the vertex up to the next viable point. Well, we have to go up 1, 2, we have to go over 1. So it's 2 over 1, or just 2. Once you've found those numbers, it's pretty easy to figure out the equation, because all the equation is you plugging in to this standard form. The a we'll replace with 2. The h we will replace with 3. And the k we will replace with 4. So if I were to have this as an equation, this represents this. If I type this into a graphing calculator, this would spit this out. The next one. Find the formula. Okay, once again, this is 0, 0. This is the parent function. This is just to show you how it's changed. So we're going to put a little dot there at the new one. So first we're going to find the h, the k, and the a. The h, x value. So find the x value of the vertex. It's -4. The k is +2. And the a, from the vertex to the next possible point, which is up here, you go up 1, you go over 1, 2. So it's 1 over 2. And all we're doing is plugging, once again, we're just plugging it into this standard formula. So a, 1/2, x minus h is -4, plus k, which is 2. Now, you'll notice that we have a 2 minus signs here. So we actually have to change that before we can go on. It'd be x plus 4, because 2 negatives makes a positive, plus 2. And this is what your equation would look like if you were trying to graph that. Now, that brings us into how to actually graph it. So, when you have this, what you first need to find is your h. That's your x value of the vertex. The x value of the vertex is always found within these two walls. So we're looking at that. But you'll notice it says -2. Our h is always the opposite of what this is. This is a -2, so our h is a +2. X, y. Okay? So we're going to plug in this into the middle. This is what will let us make the V shape that we want. So we put two numbers below it, 1 and 0 are smaller, and then we do two numbers above, 3 and 4 are bigger. Then step by step, we are going to plug each of these in for the values. So 0 is our first value. So we're going to take 2, absolute value. Instead of writing this x, we're going to write what the x is right here, which is 0. -2. Okay? Then first we do what's inside the parentheses because there's no variables here. 0 minus 2 is -2. Now this is saying take the absolute value or make the number inside positive. This number inside is a -2, so we have to make it into a +2. So it's going to be 2 times 2 actually, which equals 4. Next we do the same thing with the 1. It's going to be 2 times x minus 2, which, not x minus 2, 1 minus 2, because we have a 1 there, which is going to be 2 times the absolute value of -1, which equals 2 times a +1, because remember, anything that's absolute value turns positive. I'm just going to quickly do the rest of these just to show you the pattern. Okay. Just letting you know right now, notice how the 1 stayed as a positive one. It's only when it's negative does it change. When it's positive, it stays positive. So whatever comes out of here, it needs to be positive. Do not write a negative number. Last but not least, okay. Now, I want you to notice our answers. The h is the middle, okay? This is technically the x value of a vertex. So this means this is where things start coming off of it. So notice how it's the same number. If I were to continue on, it would just keep going the same number back and forth. Even though the x's change, the y's will start repeating back and forth. The reason is because if I graph this at 0, if I show you all the little points, the first point is 0, 4, next point is 1, 2, so 1, 2, then it is 2, 0, 3, 1, 4, 4. It makes a V shape in both directions. So these are equal distance apart from each other, and they keep going up in the same way. Okay? That's how absolute values should always be graphed. Last but not least, okay, we see positive 5. So first let's find our h. Our h is always inside, so we're going to look inside. It's this number. And it's always the opposite of that number, so it's going to be negative 5. I'm going to make an x, y, t chart. Negative 5 is in my middle. Negative 6, negative 7, negative 4, negative 3. Okay. I'm going to plug all these in here. So the first one is going to be 7. It's going to be plugged in. So it's going to be negative 7. We're going to plug it in instead of this x once again. Plus 5 minus 2, which equals the absolute value of negative 2 minus 2, which is actually the absolute value of 2 minus 2, which is 0. Okay? Same thing with the next one. So it should be negative 6 plus 5 minus 2, which equals negative 1 minus 2, which equals 1 minus 2, which equals negative 1. And this next one will be negative 5 plus 5 minus 2, which is actually the absolute value of 0 minus 2, which equals 0 minus 2, which equals negative 2. Now going off of what we learned from what we just learned, things should always repeat. That means if I get these two numbers, I can get these two numbers pretty quickly because they should be the same going out like that. So that means that negative 2 is our center. So that means that it needs a negative 1 here, and it should also have a negative 1 here. If it has a 0 here, it needs to have a 0 here. That's a quick way of doing this. That way you don't have to do the whole thing. And you'll notice when we graph this, it will make a V. And if we graph it doesn't make a V, we screwed up somewhere. And that's how you graph